In this video, we're going to talk about how to create perpendicular bisectors, and then we're going to talk about some of the applications that they can be used for. First, let's talk about what a perpendicular bisector has. And its definition actually comes very directly from its name itself. So for example, the word perpendicular corresponds to two angles that are 90 degrees. So, one thing you must have on a perpendicular bisector is a 90-degree angle. Now, the word bisector is talking about bisecting a side. When you bisect a side, you chop it exactly in half, or you split it in half. When you split something in half, you also are finding the midpoint. So whenever you're trying to remember how to make a perpendicular bisector, think about what the word perpendicular means. Think about what the word bisector means. Now, what can perpendicular bisectors be used for? Below, we actually have a pretty good example of what they can be used for. The question's asking, can they be used to find the center of a circle, find an equal distance from all 3 points, or all of the above? Well, the answer is all of the above. So you can use a perpendicular bisector to find the circle, the center of a circle, which will lead to finding a radius, which is from the center of the circle to the circle itself. And it can also be used to find a fourth point that is equidistant or equal distance from 3 other points. So let's start by circumscribing this circle to try to find its center and its radius. The first step is to pick 3 points. I suggest picking them far apart. These 3 points are what we're going to try to find the center of the circle with. So we're going to connect all those with a ruler. Now, we can find the perpendicular bisectors. First step is finding the midpoint, which is halfway between the 2 vertices on any given side. So to find a midpoint, we need to measure a side. If I measure this bottom side, I'm getting about 4.2. Half of 4.2 is the distance to the midpoint. Half of 4.2 is 2.1. So I'm going to go over to 2.1. That's a midpoint. To indicate that it is a midpoint, I need to label each of the segments that it created when it bisected this side. This is going to be 2.1 centimeters, and this is 2.1 centimeters. But don't forget, in geometry we've got another way to indicate that these 2 bisected segments are equal. We can use tick marks. I decided to put 2 tick marks on this side. I really could have chosen any number of tick marks, but once I chose how many, I need to make the other side exactly the same because they're actually both the same length. Now we're going to go ahead and measure the other 3 sides. If you're doing this at home and you pick 3 points yourself, you may have different side lengths, and that's okay. The only thing that's actually going to be the same is where your center is. So if I measure this, it looks like it's about 3.4 centimeters. Half of 3.4 is 1.7. So I'm going to measure about to 1.7. I'm going to write 1.7 centimeters on each side. And now I need to put some tick marks to indicate congruency. But I can no longer pick 2 because I already picked 2, and since 1.7 is not the same as 2.1, I'm going to have to put a different number of tick marks. I'm just going to put 1. I'm going to go ahead and measure the last side. Looks like it's about 4.8 maybe 4.9. Let's just go with 4.8 because it's easier to divide by 2. So if I do that, this is going to give me 2.4 and maybe just a little bit more since this was closer to 4.9. So this is going to be about right there. I'm going to put 2.4, maybe 2.45 on each side. Then I need to put tick marks. Now since 2.4 is different than these two, I can't use 1 tick mark or 2 tick marks. I'm going to get crazy today. I'm going to go with 4 tick marks, as long as I'm consistent. Okay. Now, I've created the midpoints, but I haven't completed the perpendicular bisectors because I haven't created the 90-degree sides. That's why I've got my handy-dandy note card, which indicates that the corner is 90 degrees. The thing about perpendicular bisectors is you can just put the card directly on the midpoint, and as long as the bottom part of your card is right on the segment that your midpoint is connected to, your card's ready to go. And you can draw the perpendicular bisector along the side. Now I want you to notice something that makes this different than medians and altitudes, really. The thing about perpendicular bisectors is they just kind of continue forever because you don't know where they're going to intersect. So you just got to make them pretty long. I'm going to do the same thing on this side. And I've got one more. We'll see how accurate I was. Looks like I did pretty well, especially using a marker. So, this point right here is equidistant to all of the 3 points of our triangle. And more importantly, this is exactly the center of this circle. So I'm going to put an arrow to this point and label that the center. If you have the center of the circle, it means you can also find its radius and its diameter. Let's focus on the radius. The radius is half the diameter, or stated another way, it's the distance from the center of the circle to the circle itself. This is the circle around it. So I can take my ruler and measure that distance, and that's going to give me the distance of the radius. So if I go right here, starting from the center, and measure to here, it's about 2.5. So this radius is about 2.5 centimeters. Now, there are 2 other examples on this page. They're both done very, very similarly. So if you wanted to find a point that is an equal distance from, say, A, B, and C, what you'd have to do is draw in a triangle and then find the perpendicular bisectors. Where they intersect will be a 4th point, you could call that point D, that is equidistant from the other 3 points.